Determine the missing properties and the phase for water in each of the following states. For each case, we have only two properties. As discussed before, the state of a thermodynamic system can be defined by only two independent variables, and all other variables can be determined from those two. In example 4, the pressure and enthalpy are given, but we don't know the material's phase and which table to use to determine the missing properties. To determine the phase, we first go to the pressure table for saturated water and find HF and Hg values. At 5,000 kilopascals, HF is 1,154.5 and Hg is 2,794.2 kilojoules per kilogram. Using these values, we see that the enthalpy of 2,000 kilojoules per kilogram falls between the HF and Hg. Therefore, we have saturated liquid-vapor mixture, so the temperature must be the saturation temperature at the given pressure. We can read that from the same table. The saturation temperature at 5,000 kilopascals is 263.94 degrees Celsius. And finally, we can calculate the quality from this equation using the enthalpy values. This example is similar to previous one, except the enthalpy is different. Similar to example 4, we find HF and Hg at 5,000 kilopascals or 5 megapascals. Since our enthalpy of 3,000 is larger than Hg, we have superheated vapor. Using the superheated property tables at 5 megapascals, we see that H equals 3,000 is between 2,925.7 and 3,069.3, corresponding to temperatures of 300 degrees Celsius and 350. Using linear interpolation, we can find the superheated vapor as temperature between these two values. Example 6 is similar to examples 4 and 5, but with a different enthalpy. We start by finding HF and Hg at 5 megapascals. Since our enthalpy of 1,000 is smaller than HF, this is a compressed liquid phase. Using the compressed liquid table at 5 megapascals, we see that H equals 1,000 is between 944.32 and 1,037.7, corresponding to temperatures of 220 degrees Celsius and 240. Using linear interpolation, we can find the material's temperature between these two values. Examples 4 to 6 are related, so it is useful to summarize their answers in this table. We can also locate the thermodynamic state of each example on the phase diagram. Example 4 is in the saturated liquid-vapor mixture region at pressure of 5 megapascals and saturation temperature of 263.9 degrees Celsius. Example 5 is in the superheated vapor region at the same pressure and a higher temperature. And example 6 is in the compressed liquid region at the same pressure and a lower temperature.